joining today's webinar. My name is Jim McGann with Index Engines. Today's topic is talking about data disposition strategy. Really looking at user data, unstructured user data, files, email, content that's scattered about the network, and building a disposition strategy. We're going to talk about a case study from it's actually a number of different customers. We can't really use their name, but we'll kind of talk about some typical scenarios that we see in the field. If you do have questions, there's a chat window, a question window there on the bottom right. Just feel free to type the question in, and we'll take them during the session. My email address is on the screen as well, and you can send direct emails. I'll put that up at the end as well if you do have questions towards the end. For those companies, for those people attending that do not know Index Engines, I apologize, the screen was just told the screen was not displaying, and get past these technical difficulties. There we go. For those people attending who do not know Index Engines, we are focused on information management. We're an indexing platform, hence the name of the company, focused on really data governance, data management. It's all kind of converging together from the very specific use cases of e-discovery and long-term retention to doing security audits, compliance audits, down to really managing unstructured user content across the data center. Our simple focus is really to help find data, manage data, govern it, and support policy-based information management. We're located in New Jersey on the east coast of the U.S., founded about just over 10 years ago, about 12 years now. It is uniquely patented. It's architected for large-scale indexing environments that talk of data in petabytes in global distributed environments, including network data as well as other formats such as backup data. So this is an actual customer scenario. It's been a little bit masked to hide the customer, as they do not want to publicly talk about what they've done. But the initial challenge was they had a number of different servers that had sensitive content that needed to be cleaned up. They were under the microscope from a regulatory point of view. And they did this across a number of different servers. This one server was, in this example, is a 100 terabyte server. It's really their client services department. So one of their concerns was finding sensitive content, patient data, or client data, records, and so on that are existing on the server. Typically, it's been unmanaged. It's one of those shared network environments that most organizations don't manage too closely. It contains documents, contracts, client records, PSTs, email containers, which was one of the bigger concerns for this client. And it was one of those servers that had been upgraded year after year and was facing another upgrade as it was reaching its capacity. They were increasing their storage footprint about 30% year on year. So one of the things that really incented them to do something here was really kind of eliminating a costly upgrade for that data, but also looking at the risk and the liability of that content. You know, one of the things that was a concern, as I mentioned, was PSTs, typically in email content. So the deployment really, it was a project that was initiated by the IT organization and really run by their records team or their compliance and records management team. But really the IT organization really took the responsibility of setting this up and deploying it. One of the beauties of the Index Engines platform is it can be set up as a virtual environment using a virtual server or a physical server, so it's very easy to deploy. So the first step was really kind of, before they made any policy decisions, was really understanding what exists. And that's really critical for organizations that are in the process of trying to develop policy. If you really don't understand what you have, it's very difficult to develop those policies. We have one customer that had developed a policy that eliminated PSTs being created across their network. On the first audit or data assessment that was done using the Index Engines platform, they found thousands and thousands of PSTs that existed on the network. So again, it not only helped clean that data up, but also helped audit and refine the policy that was created. Once the understanding or once the view into the content is created, analyzing the content to be able to help understand what exists and looking at it to help develop policy, and then determining disposition, which could be leaving data in place, but it also could be migrating data to different tiers of storage, archiving sensitive content, defensively deleting what has really no longer any business value, and then executing that policy initially, as well as developing ongoing scheduled execution of that policy. So in the phase one, which is really kind of the data profiling phase, it's really looking at sample reports. I'll have some sample reports shortly, and looking at the unstructured user data and emails, including PSTs. And really, they were looking mostly at metadata level reports, so looking at dates, last access, created, modified date, owner, location, size, types, duplicate, and so on. The important point for them, and one of the key reasons they really implemented the Index Engines platform, was the integration with Active Directory. So Active Directory really defines your department or group permissions on the network. So if you're in the research department or in the finance department, you would be a member of the finance or the research Active Directory group. One of the other key things that this organization did was, as employees left, they would maintain their Active Directory membership, but they would move them to an inactive user group. So you can kind of do a query across the network, say, show me all data owned by inactive users, which are basically ex-employees, non-active employees. And that was very appealing to them here. This chart's a little bit dense, but the Index Engines platform has significantly flexible indexing levels. For network files and email, you can do a very light metadata level, so which is looking at things like dates, owners, locations, file names, extension, size, and so on. Or you can do a deeper metadata level, which really goes inside the email databases and would get things like mailbox listings as well, and get some of the email metadata. Would also create document signatures for duplicate and redundant content. So light metadata, very light touch, deeper, obviously more intense profile of the content. Again, I mentioned Active Directory integration as a feature to get group members looking for things like inactive employees or doing roll-ups. We have some customers that use Index Engines to do chargebacks, for example, and they want to look at servers or network data capacity and say which department is using what percentage of the capacity out there on the network, and let's charge them back for that. Also Index ACLs, I talked about security permissioning. This is going to give you read, write, browse permissions of the files. So the network is filled with very rich metadata, so that the beauty of the platform here is that this metadata is harnessed and captured so that you can do reports, queries, filters, and so on the data and search the content. And then finally, there's full text, which was not used in this initial case, which full text is going to do file and email full text content search, so you can do keyword search on the content, pattern search as well, looking for things like PI and patterns. So that's really in the network files. Also very similar for backup data is the same platform does indexing of backup data, not the real focus of this session today, but you give a sense of the depth and the breadth of the platform for what data is indexed. So in terms of phase one, there was sample reports. So the common ones are looking at data which is really the redundant, outdated, trivial data, or ROT, which we'll talk about in a minute. But really the age data, data that has not been accessed, so more than, they use 3 years. If no one's really touched the data in 3 years, it's aged out of any usefulness. Abandoned data, very similar, although if you can add to that 3-year time frame of not being accessed, add the Active Directory membership of ex-employees or inactive users, and if data is owned by inactive users that hasn't been accessed in 3 years, that data has either outlived its usefulness and doesn't have any value, or it could in fact be data that does have value that has been lost on the network. Duplicate content, looking for redundant data, and that can be done using a document signature or MD5 hash of the system, or it can be done looking at file name, path, size, location, and so on. If you're looking at using the metadata properties to define what duplicate data exists. Sensitive data such as PSTs, where are all the PSTs on the network and who owns them. Sensitive things like keywords and PI, personally identifiable information. That's really with the full content indexing that's available. You can find that sensitive data. Multimedia files, this client was looking for any data that may not have any business value, such as users, and being that this was a customer service department, there was a lot of junior employees that were rotated in and out of the organization that would be saving their iTunes libraries, vacation photos, downloaded movies, and so on the networks that they brought in to work with them. And this data taking up a lot of space and easily found. And then there's the active data, the stuff that's being accessed, modified, created within the last X number of years. Where is that data, who's using it, and how is that data changing? Looking at the dark data, again, the stuff that has some type of intellectual property or some value for the organization, but has not been accessed in a number of years. And that data could be hidden, so there could be some searches or keywords to find that content. We have one client that has old manufacturing documents that were kind of lost and aged in the system, so they're using the Index Engines platform to be able to index that data and do searches on keywords or types of files or owners and so on to kind of harness that old intellectual property and leverage it. Here's some sample reports. You can see some of the rich GUI or the rich reporting capability. The important point in the reports is they're dynamic. So you can go in and you could select, you see the check boxes here on the left. You can kind of pick and choose and uncheck certain components within the reports and dynamically filter and modify them. You can see also here there's file listings, there's queries, in this case that's keyword queries, here's filtering based on file types, here's different components of the web interface. Here's reports on access times by different categories, and within there you get the file count and the total size of that data. If you're doing full content in the file listings, you can see the files here, and then you can see what we call the reconstruction down below. This is showing some PII data that's being highlighted for that query. So the second phase is the analysis and classification of the data. So really looking at the data of value, which is the content that users are actively using, stuff that's active or dark data, that's old research data or old reports that may have value. And you can do that by department too. So you can say if there's a research department or maybe a legal department, there's old contracts that may have value. So you can say, show me all Word documents or PDFs or WordPerfect documents that are owned by anyone in the legal department that has not been accessed in a number of years, and kind of use that and summarize it so that someone in the legal department that has some knowledge of the data can look at it to see if it does have value. So managing data value, ensuring that it's available and people have access to it and know that it exists. The age redundant data, really the ROT, the redundant outdated trivial data, looking at migrating that to cheaper storage. Some customers look at that and they do defensible deletion to get rid of that content. Some customers really want to migrate it to a different tier, and a lot of customers are looking at cloud storage as a tier because it's so cost effective. So if you're not able to delete data, even if no one's really accessed it or it doesn't really have any business value any longer, it could just be a simple migration to get it off expensive primary storage. And then sensitive data, find the stuff that may be email content that may have sensitive customer records in it, or PSTs across the network, or building queries that say find me all PDF documents from the legal team or Word documents from the legal team that would be typically contracts or sensitive data. And migrate that data for an archive for long-term preservation, keeping the index available to be able to find and manage that content. So if you look at the environment, so this customer that we're vaguely talking about has numbers that fit within these ranges. So looking at 100 terabytes of storage, they found that between 20 and 40% is redundant, and that's pretty typical that we see out there. It depends on the type of business. Some are more extreme versus others, but 20 to 40% data is typically redundant. 10 to 20% is aged and no one's really accessed it. 18 to 22% of it is abandoned. The owner does no longer exist. And if you combine these two categories, you're getting upwards of 40% of age data that exists on storage that you're paying, annual cost for to manage and support, but no one may be accessing up to 40% of that content. 4 to 10% contained sensitive content. They were on the higher end for this customer service organization. There was a lot of sensitive customer records there. 5 to 8% contains personal multimedia content. That's typically by capacity because those are larger files typically. And there was anywhere from 20–40% of the content, which is out of 100 terabytes, you're dealing with 20 to 40 terabytes of real active content. If you can, clean this data up that really may not need to be there and move it to a different class of storage, you really can recoup significant capacity, in this case more than 50%, and not really have to go through an expensive upgrade of that environment. So in terms of disposition strategy, the Index Engines platform that I showed you earlier, some of the screenshots, has built-in disposition. Built-in disposition allows you to kind of do the reports, do the analysis, look at the data, classify it. There's built-in tagging to be able to create categories, and then to be able to migrate it, defensively delete it, or move it wherever it needs to go. And that could be done in a one-shot, one single time frame, or on a repetitive scheduled basis. So built into the system is this disposition policies, including migrating data to cloud storage, for example. We support S3 to be able to migrate and move the content off the primary storage network. A deletion, defensible deletion, so it's all done defensively. All the data that's deleted, the person that's actually going through the process of deleting it is logged in the system. The date the data was deleted and what content was deleted, basically file names of that content. Archive, moving data to an archive of sensitive content. Encrypting data, Index Engines doesn't have built-in encryption. That's one piece that's not there, but we can provide a output text file of the full file path, name, and so on that could be ingested by encryption engines to do that. And then for the personal multimedia content, they were basically notifying management and giving them a list of users, the top suspects there are top users. If they were no longer with the company, they would just delete that content. If they were, they would notify management to go and clean that up and notify the user that that was in violation of data policies. And then execution, this occurred over a number of months. Really the indexing of the data is incredibly high speed indexing. We can index data up to 1 terabyte an hour, so getting through 100 terabytes is not a doesn't take months. But the cleanup and the policy, really the policy definition and the cleanup strategy was something that took the longest here. Users are aware of the new strategy. There's definitely now a lot of data that's been moved off the network and is archived and can be searched and found if needed for future reference. They can get access to it through this web-based GUI or through the help desk. Ongoing audits, so the policies can be run on a daily basis, on a weekly basis, on a monthly basis. So some customers run it on once a quarter to do cleanup. Some customers run it once a week. It really depends on how organized you need to fulfill this policy activity. And then the policies for managing the data in place are run, are something that's going to be a continual process. So kind of looking at data and understanding what exists as data ages out, as users leave the organization, you're going to kind of continually clean that content up. So really their success factors in the way they measured this is something that was very appealing to the legal and compliance folks, because it was a lot of cleaning up of sensitive content, sensitive data. But really the IT organization got incredibly excited about this because it saved them significant upgrades. They actually had upgrades already in plan and in budget for the this calendar year, and they canceled those because they were able to reclaim capacity. So they ended up reclaiming almost about 50% of their storage capacity, eliminating the need for an upgrade. They reduced significant data management expenses. So a lot of the impact too is if you're storing, if you're cleaning up 50 terabytes off the network, and that data is not only taking up space on the server, but you're also backing it up on a daily basis. You're managing it on a daily basis. So that reduced those costs of that as well. Because they basically get charged for backup. They get charged by how much capacity they're backing up, so that reduced those bills for their disaster recovery environment. And then really the management of the risk and liability of that content. So cleaning up, old PSTs that were on the network, old contracts that no one was managing any longer. They found over 1,000 PSTs. Most of them, more than half of them, were owned by ex-employees. More than 30% or so, I believe, weren't even accessed in the past like 3 years. So they could easily, those could disappear tomorrow and no one would even notice that they're gone. So in terms of the Index Engines platform, really focus on the data profiling and disposition. The first key component is really connecting to different data sources. So obviously network storage is one of the key components we're talking about today. Microsoft file system, Unix file systems. We could also index, desktops, workstations. We support email. We support Microsoft Exchange, including PSTs, EDBs. Support Lotus Notes. Support archives such as SharePoint to be able to index that data in place. All the indexing occurs very efficiently. The index footprint, so the size of the index, is typically 1% of the original source data. That's for metadata, up to 5% for full content. And when we index data in place, it's not copied or moved. It's just scanned and indexed. So for the online data, for the offline or backup data, we index backup tapes, disk-to-disk backups, all the common backup formats. The second component is kind of the classification and policies. And there are sample policies built into the system. Most organizations are spending time to customize and create their own. So looking for redundant data, looking for large files, which users of the system own the largest files out there and have they been accessed? Are they duplicate? Where multimedia personal files, age data, abandoned data, data with PII, risk-based data, stuff that's needed for e-discovery or legal hold, and active data. And then the third component of the system is the disposition policies to be able to either archive data, preserve data, delete data, tier it out to a different storage platform, migrate it, consolidate it, or encrypt it. So there's different solutions and different strategies, and the system is very easy to use and flexible to support all these different policies that are required. So this chart is kind of a little bit of an eye test, and again, if anybody would like a copy of the slide deck, I'll give you my email at the end. But talking about, I mentioned earlier, redundant, outdated, trivial data, or ROT, here's some typical classification policies that are available, and we also have a white paper that talks about this as well. So looking at redundant data, you can look at duplicate files owned by ex-employees, duplicate files not accessed in more than 3 years, duplicate files owned by members of specific departments like the marketing department. So you have a lot of flexibility in building these sample queries, and here's some examples of how the queries are built. And then building a matrix that shows what is the business value, for some case very low, some case low, and so on, and then based on that business value to determine where this data needs to be. So this content has very low value, can be defensibly deleted. Others that has low value can be migrated maybe to cloud storage or lower cost storage. So that's redundant, outdated data, files not accessed in more than 3 years. And 3 years is pretty common for organizations when they look at, what is age data that has, what does that mean? Is it 3 years, 5 years, 7 years? But 3 years makes sense. The query is last access query greater than 3 years. And here you can kind of look at the different organizations, so the different departments, maybe R&D, HR, legal, sales, and you'd have different business values associated with each of those different departments, which could be assigned to different disposition strategies. Some could be deleted, some could be archived, depending on the department or the group. And then finally, trivial data, like I mentioned, personal multimedia files, maybe iTunes libraries, music libraries. You could search by file type equals multimedia, which is videos, audio, images, or you can search for file path containing iTunes. Extremely low value to the organization, and that would be defensibly deletion. So some examples of different ROT analysis policies that were developed. Going into a little bit more governance-related classification, so finding data of value, simple queries could be contracts owned by the legal team. So you could look at a query which is file types, which includes Word, WordPerfect, PDFs, and so on, and Active Directory membership is legal department. That would get you all contracts owned by the legal team. Extremely high value, archive and preserve this content, move it to an archive. Looking for PII, similar thing, it's a built-in query to look at file type, of maybe EDBs, PSTs, notes files that contain patterns like credit card and social security numbers. Okay, and that data could be maybe encrypted using encryption, third-party encryption tools. Finding email like PSTs, that's simple, looking at file type equals PSTs and when the data was last accessed. Looking for user mailboxes are easy, or a security audit saying who has read access to Sally Smith's CFO spreadsheets. So you can look at file type spreadsheets and the owner, Sally Smith, and then report on the ACLs who has read-write browse permission for those files, and you can look at a one-by-one basis for that content. So that would support security audits. So you can see the depth and breadth of metadata and classification policies that can be developed within the Index Engines platform. Again, there's a lot of content here, and I can send this copy of the slide deck or a white paper to you that has this information in it, which is actually here. So I know we were planning on going 30 minutes. We're just at 30 minutes, so I don't know if I'll have time for some questions, but there are 2 white papers that are of interest. This 10 questions you can answer about your unstructured data and how to leverage data profiling to support intelligent disposition. If you do want a copy of the slide deck or you want a copy of these white papers, send me an email. My email is here, or you can look on indexengines.com. I believe they're on the website there as well. And I believe there's a few questions which I cannot get access to for some reason. Okay, so one of the questions was asked about pricing. The pricing is based on the capacity. So it's based on if you're indexing 5 terabytes versus 500 terabytes or a petabyte or 10 petabytes. We have projects that are in the multi-petabyte range that are going on today. So it's really tiered based on that pricing, and it's not incredibly expensive to get the depth of metadata that we've talked about today. One question said, does this come with a server? No, it is a software-only solution. It can be installed using a virtual VMware implementation or on a physical server Linux-based platform as well. Okay, I'm being asked to wrap it up since it is 2:30. If you do have additional questions, shoot me an email and we will get back to you, and hope you found this informative. This will be recorded for your colleagues if you'd like to share a link. Thank you very much and have a good day.